Everybody can see my screen.
Yes.
Yeah, I can see.
Can you make a full screen? Yeah.
Is it okay now?
Yeah. Perfect.
Yeah. Hello everyone. Welcome to today's session of ST Skills. So today's session is on linked list. So where I have picked up 3 problems around linked list. Those are typical medium-sized problems. And what I've seen that these problems are very common in the initial rounds of interview. And there is no as such algorithm involved in these kind of problems. What I've seen, it's more like a pattern, and we would be discussing the same. Okay. The first problem is a reverse linked list. So there is another problem on a lead code, which is an easy problem, which says that you have to reverse the link load from end to end. The only change in this problem is you have to reverse a link load between 2 particular nodes. So say for example, you have given an input 1, 2, 3, 4, 5, and 2 indices are given m and n, like m is 2 and n and 4. So you have to reverse only this part of the linked list. So the output will become 1, 4, 3, 2, and 5. So anybody has any thoughts, approach, would like to pitch in how we can solve this problem?
Maybe since we're doing it in one pass, you could still use multiple pointers, but have a counter that can ensure that it's only going to reverse the nodes that are between the 2 beginning and ending.
Yep, that's good. Yep, that is one approach. Somebody has any other approach?
We can have 2 helper functions. One can be insert at first and another can be to insert at the last. And we can traverse the input linked list. And every time if we are in the range of m to n, that means insert at last, else insert at first. And we'll have the correct output string in there.
That looks interesting. Would you like to share, or would you like to code?
I can try. So how would it go? I share my screen or? Hello.
Yes, you can share your screen if you are okay.
Mm-hmm.
Yeah.
Hey Raghav, we can't hear you.
I think we lost him. Yeah.
Raghav, we can't hear you.
Yeah, sorry, I lost my connection somehow. So are you going to, is someone is going to share the screen about that helper function approach?
Yeah, just give me a second.
Yeah, so in the meantime, I will tell how I did. I followed the first person name codes. So I also follow the same way. I used a 3-pointer approach and shifting the pointer after changing the pointer nodes to the previous pointers. So that is my approach, having a condition that we have to solve it in one pass.
Or you want to share the approach?
Yeah, I can share my approach. Let me do the whiteboard. So let's suppose you have given a node like this 3, 4, 5. And we have to reverse this part, which is M and N. So we can have a 3 pointers. So the 3 pointers would be like this, like a start, sorry, like pre, start, and then we can have a 3 pointers. So the idea is we have to insert a then pointer between pre and start. And once you insert a then pointer between pre and start, we will shift the then pointer by 1 step. So to make it more clear, so initially, let's suppose the pre is this, start is this, and then is this. So in the first pass, so it will become like this. 3 will shift here, 2 will go here, 4 will go here. So the pre and start pointers remains at the same position, but the then pointer, which was at third index, it will shift to next step over here. So in the next iteration, we will again shift the then pointer between P and S. So it will become 1, 4, 3, 2, and 5. So then we'll go again next step, but we would be having a terminating condition. We will traverse this loop starting from M, ending with N. So this is the high level approach. And I'll show the pseudocode over here. So this is a solution of this approach. So we have created one dummy node, okay. And as we have given M and N, which is here M and N, so we have to make sure that our pre node should be one node before M. So which would be one before, then only we can follow this approach. To do the same, I have ran a for loop where I have set the pre node to pre.next, and initially the pre is dummy. So the moment I reach to the M minus 1, it means I have set this as a pre node. So M and N can be given somewhere here also in another test case. So in that scenario, the M would be somewhere, the P would be somewhere here, start would be here, and then would be here. Then I have another 2 pointer start and then, which is pre.next, which is a start pointer. Initially the pre P was here, start is next, and then is next of that. So the first, these 3 steps, we are doing nothing but initializing the pointers, that's it. So this is the actual loop which I just spoke about. So if you see, we are doing n minus 1. The then pointer, we are shifting between P and S. So how we are doing? If you see, once that then pointer is going between P and S, so two next pointer is starting pointing to 4. Okay, so it means start dot next equal to then dot next. So in the first step, so your 2 will started pointing to 4. So basically it is happening over here. So then dot next equal to pre dot next. So because then has to go here in between, so it means pre next should be equal to then dot. So that's why then dot next, pre dot next, and pre dot next equal to then. So I think I missed it. So we'll start again. Start dot next equal to then dot next. So 2 next would be 4. Then dot next, which is 3. 3 should be pre dot next. So pre dot next is 2. It means 3 is pointing to 2. So 3 is pointing to 2. Then pre dot next equal to then. So the 1 should point to 3. So pre dot next should be then. So it will become, what is then? 3. So it will become 1, 3. So in the last step, what we were doing, we are shifting a then pointer to next step. So once then pointer is inserted between pre and start, we are shifting a then pointer to next, and that is start dot next. So start dot next was 2. 2 next pointer would be become a then. So is it clear or is it confusing, or am I going too fast?
I felt like the part on reversing makes sense, but to get to the dummy node, I guess the thing I don't understand is like making sure that, oh yeah, so you have the range here, so you don't have to worry about the end.
Yeah. So the first is we are identifying a pre-node by having m minus 1, and then we have a range n minus 1.
So the pre-node in the first for loop, we are going till m minus 1, right? So then it will be m minus 2. It will go until m minus 2, right? From 0 to m minus 2 it will go, because it's m minus 1 and it's less than m minus 1. So I think it will set to m minus 2, right?
Yeah, but if you see here, our m is this, which was 2. Okay.
Mm-hmm. So you are going till m minus 1, which is nothing but 1, right? 2 minus 1. So
but
and
if
then
you see
I less
this,
than.
It's a 0 index.
it's a 0 index.
It's a 0 index. Yeah, so that's what I'm saying. Like in the for loop, we are going till m minus 1, which we are going till m equal to 1, right? In the for loop. M is 2, but what I'm saying is we are going until 0 less than 1. So we are
if you see, I got your question, what you're trying to say. The thing is this, there is another step. In the first condition, the pre is belonging to here, not here. Okay, so if you see, we have created a dummy node, okay, and the pre is pointing to dummy node, and dummy node is 0. So the pre is here.
Okay,
okay,
the dummy node
so
is a pre.
Dummy node is pointing to pre, so that's why m minus 1. Other way around is you can, yeah, because you don't know the m, and there may be a test case where m is given over here, right? So that's why you have to point pre node to a dummy node.
Got it. Yeah, because in this example, the for loop will not even execute, right? Or it will execute once.
It will execute once.
Yeah, it will execute once.
So I think this is more clear. So initially the pre-node is pointing to this dummy node.
Yep.
Okay, I think someone else wants to share the helper function approach. Are you ready?
Yeah, okay.
Uh,
Uh, can you guys see my screen?
yes.
Yeah, so I was talking about we can have two helper functions. One can insert at the starting of the list, and another can insert at the end of the string, end of the list. And idea is to reuse the same node. So we keep on traversing over the list, and we can keep a counter. And if counter is between m to n, that means we can insert at the start, like in the new list what we are creating. That means if we insert at the start, we are reversing it then, and else we just take the node and just keep adding at the last.
Can you go a little up? I want to see the insert at start and insert and end.
Yeah. These are normal. Okay, I got it. There's one problem with this approach. So it would be like first 0 to m, we have to insert at the end. And then m to n range, we have to, okay, so yeah, the problem is we have to consider this subsegment.
Yeah, so will it work for the scenario where m is at index 1?
Yeah, so the problem, I got the problem with this approach. So the problem with this is, when you will be in a range of m to n and you will insert at the start. So these m to n nodes will just shift at the starting of the list, which is not good. And we don't want this. So yeah, I mean, we can rework on this logic that with the helper functions, we have to ensure that if we are in the m to n range,
I think this works for the other reverse linked list problem where you don't have m to n. So there, because you don't have a subset, then it works very well.
Right. Actually, the way I'm thinking was that so what we are talking about is we are actually talking about three sublists. Range 0 to m-1, then m to n, and then n to end. Right, and we only want to reverse one of the list, and so I think I'm messing up while attaching them. So the point is, if you are in 0 to m-1 range, just append them at the last. So you will have your one list.
Right.
So we can have three sublists. Point is that, and just we need to reverse one and then reattach them in proper order.
Right. So even in my next problem, I'm using similar kind of approach where I'm dividing the list into two sublists. So I think probably there we can get an idea of your solution as well.
I have another approach. It's similar to you, Raghav. But what I do is I create a reverse function. I mean, yeah, reverse linked list function. It reverse from the head to certain index, right? So what I'm doing is like I just go look for the pre first, and I pass the the pointer, to the pre, to that function, and that function will reverse the, do the reverse, and then, return the result. That result gonna append to the pre. So for example, I have the function that reverse, you given a head of the list, and then how many elements you want to reverse, right? The reverse from the heads of the list. So what it goes, just reverse from the head of the list to that index, and then return the result. So that way, I don't need to keep track of the pre, Does it make sense?
So what I understood is your proposal is we are going to have a reverse function where you would be inserting the index.
Like you see that in your for loop, right? In there you have for loop, I attract it to another function, right? Attract the second for loop to another function. And that function, it knows you reverse from the head to that, to M, right? The reverse from the head to the M, and then return the result. And then I just append that result to the pre-pointer that you have.
What does it return? Sorry.
So if you think about, like we have, okay, look at the example we have on the top, right? We have 1, 2, 3, 4, 5, right? And let's say we want to reverse from 1, 2, 3, right? So what I do is I just go and pass in the pointer to 2 to that function. And that function will reverse the, do the reverse from reverse 2, 3, and 4, and then return it back to me. It's just like that way. I don't need to keep track of keep updating the pre, pointer.
So basically, you are trying to say that over here where we are doing pre.next equal to then. So this part we don't have to do it every time. So this part would be replaced by some sort
another
of
function,
reverse, some sort of reverse function which will take M and N as input. And it would return you a list.
And I append that list to the pre.
That's and that list finally, but again, whatever list you are returning, if you see then is nothing, it's a list only.
It returns the head of the result, right? In this case, the head of the result will be 4, 3, 2, 5, right? I mean, so I append that to the pre.
Yeah, so I think I got your idea. So instead of having shifting the pointers of then between P and S, you are trying to say have a reverse function. And we have another classics pattern to reverse a linked list from end to end and follow that. Maybe here we would be having 2, 3, 4, and this function will return it 4, 3, 2. Okay, using a classic reverse linked list solution, and then append it directly to this pre.next.
Right.
So there is no need to run. Yeah, that can also work.
But we
I just try to avoid to update the pre, because it keep it might,
if you see over here, this pre.next, this part is always same. Okay, this we are not changing pre anytime. Okay. Yeah, someone is trying to jump in. Yeah, go ahead.
Yeah. So what I'm saying is that after reversing this 2, 3, 4, we get 4, 3, 2, right? So we can attach the pre to the head, that is 4, but we also have to attach 2 to 5, right?
Right, I pass the whole thing into the function, so it's going to return back 4, 3, 2, 5, right?
But if we have to reverse this part only, like 2, 3, 4, not 5. So 5 would stay as it is.
Okay, so what I pass in that function, if we look at the first line, I pass in the pointer to 2, right? If we look at the first, the example in the input, I pass to that function the pointer to 2. The function just, do the reverse, from the head to M, right? And then they return the result.
So,
it might not, yeah, go ahead.
So I think what you're trying to say, like, for example, this 5 needs to be attached to this 2, like the reverse thing, correct?
Yeah,
like,
that's what.
Okay, so the function can reverse everything or reverse only a partial of it, right?
So actually, we can return 2 things in Python, like.
No, I return only one thing. Okay, so for example, I pass in 2, 3, 4, 5, right? But I pass in the, the pointer to the head, which is 2.
Yeah,
And now
I think
I reverse it, and that returns to me 4, 3, 2, and then 5.
Yeah, because it's a linked list, I think you don't have to attach 5 to it. Even though you pass the starting pointer of 2 and then you reverse until this reverse the list partially, so the rest of the list remains the same, and then you just attach 2 to 1, like the reverse list, which is 4 to 1. That's it. You don't have to.
Right.
You don't have to do like go and attach the 5 or the rest of the remaining list.
Yeah. Makes sense. Yeah.
Yeah. Okay. Yeah. I had another question if we are done with this one. So I just wanted to talk to, ask that question to Raghav.
Yes, Sumit.
Yeah. So I know that this question has this condition about the length of the list, right? So when I saw this for loop, which is going between n minus m, so suppose there is a little bit of a variation here in this question where this condition is not there, like n and m, or like n can be out of the range, right? So is it something which we can take care of this in this for loop, or we have to check that specifically by going through the whole list, whether it's out of range or not?
Yeah. First of all, in the question statement itself, the condition has been given that it will be
Yeah,
null.
exactly. I'm just discussing a variation of it, like just.
Okay. Yeah, we can just put a guard condition in the top to handle that scenario.
I have one doubt actually. I joined late, might have missed it, but the question is said we have to only do a single pass. But I think we are iterating twice some of the nodes, like until m.
That's the one pass, right? That had 2 for loop, but the first for loop is find the pointer to the pre.
Yeah, this is one pass only, I think.
It just moves the pointers up.
Because with yeah.
Though it's a 2 for loop, but I think it's doing one pass. Yeah.
Okay,
But,
got it.
Yeah.
Yeah, now I got it. I didn't check the second for loop condition.
Yeah. So going back to the previous question, I was just thinking, like, can we check for then dot next to be null or something, and then make that check right here in the for loop instead of checking the length of the. I mean, definitely we can do here. We have to do certain checks, because if we have to do it in one pass, then we cannot check for the length first and then go through this logic. But it has to be checked for certain null pointer and all within this second for loop. Does that make sense?
Yeah, maybe I like
think
the
we can
for
handle
loop one.
these.
M and N will be within the length of a list only. So they have mentioned this.
Yeah.
So what he's saying that if variation of question comes where they say that n can be out of range. Yeah, I think all these can be handled in a different ways by putting a guard condition either in the top lengthwise or just by putting then dot next should not be null. Either way it should.
Yeah, makes sense. Okay. Thanks.
Okay. Anybody else has any questions, or everybody understood, or do you want me to recap, or can I move to the next question?
I just have a quick question about the recursive approach. I solved it with using recursion, but it timed out when I sent it to LeetCode. So I was just curious if somebody was successful in doing it with recursion. We can take it offline too if it's better.
I did not solve personally on recursion. Maybe someone else can jump into if they have any thoughts, or we can take it offline.
Yeah, I think the recursion is like we check for null, right? So I think instead of checking for the null, you check for the n node, the whatever is your, yeah, that condition will be tricky there to reverse a linked list. And maybe the same approach what Leon was talking should work there.
No, I think it, if it run out of time, maybe it's like infinite loop, right? Otherwise, it's going to be stack overflow, right? If it run out of stack.
I mean, LeetCode has a timer, right? So, but it's a good point. Like if it goes out of the time, it might not be an infinite loop, but if it takes too much time.
Yeah, that's what happened to me.
Yeah. But it could be like when you do the pointer, maybe you point it back, make it become circular linked list.
In my case, I'm using just the stack of the recursion. You know, when it goes back, that's when I'm like wiring up the nodes. So still one loop, it just still times out for some reason.
Martin,
sorry, go ahead.
Maybe if you share the code, a quick look to see.
Yeah, you wanna take it offline, or you want to do it right now?
I think we can take a look. I don't know how Raghav's timing is, so.
Yeah, I'm okay. I'm okay with that. Yeah,
a good variation.
whatever works for the most of the audience. Yeah.
Yeah, it's a good variation to understand, right? So.
Yeah, Martin, you can share your screen, please.
Okay.
Because we already discussed about recursion sometimes, so.
Can you see my screen?
Not yet.
Not yet.
How about now?
Yeah.
So, yeah, basically I solved the simple version of this, the reverse linked list one, with this exact same approach, and it works. That does work. So this one is basically, I send an in here line 47 to to do the stitching of if it's within the range, and then the one check I had to do is that sometimes you have to return the end node, and sometimes you have to return the current node, depending on if the start is 1, then it's the whole list got switched. And yeah, like I said, this seems to work. I was just printing the values and seems to do it right. It's just.
Oh, Martin, your voice is breaking a lot, actually. So I don't.
It just times out. So I guess that's where I'm a little bit stuck. But the basic idea. Oh, is this better? Hello? Yeah, sorry, maybe it's my microphone. Maybe we can just take it offline and.
Yeah, I don't know. Your voice was breaking and it's slow. I think there is a connectivity issue. So,
Okay, I think I'll share the code offline. Would that work?
yeah.
Okay.
Unless somebody else wants.
Maybe in the
Yeah.
chat. So
Yeah.
maybe in the chat. So I think when you turn on the video.
Okay, I will.
Okay, I think we had some technical issues with Martin's microphone. Probably Naga, you can check with him offline, or we can have some other session where we can discuss the same.
Sure.
Yeah, moving next. So the second question is reorder list. The problem statement says that you have a singly linked list starting from 0 to n minus n, and you have to reorder in such a way that you pick up the first element from the starting of the list, and the second element, next element would be the end of the list, like L0 n, then you pick L1, then second last, then
Can you
third
share the
from the start.
question?
Hey Raghav, can you share the screen?
Oh, I'm sorry. Can you see my screen?
Yeah.
So the question is reordering a list. So where we have given a linked list starting from L0 ending with Ln, and we have to reorder in such a way so that the first element from the list, then second would be Ln, then the third would be L1. So basically we are picking one element from the start, and the next would be from the end. So if you take an example, 1, 2, 3, 4. So it will become 1, then pick the second one from the last 4, then 2, then n minus 1, like that. So L0, n1, n minus 1, L2, n minus 2. So second example is 1, 2, 3, 4, 5. So we will pick 1, then 5, then 2, then 4, then 3. So output will be 1, 5, 2, 4, 3. So anybody want to put their thoughts, approach on this?
I think you can go to the mid of the linked list.
Sorry, come again.
Sure. What I was saying is, if you go to the mid of this portion,
Yes.
reverse it. So it will be 5, 4, 3.
There's some
One
echo coming.
pointer at 1, the other at 5. Now just keep on adding, like keep on adding 1 with 5, and keep on incrementing the pointers till you hit 3.
Yep. Yeah, that can work well.
Yeah.
I didn't get that. One pointer at 1 and other pointer at 3. So
First I founded the mid of the linked list at 3, right? Now just to reverse it. Once you reverse, you will have 5 over here, and 4 at this portion, and 3 at this portion. Now keep your one pointer at 5, the other at 1, and just keep on concatenating 1 with 5, and just increment 1 with this, and increment this.
Makes sense. Okay. Reverse the second half. Okay.
So Shashank, would you like to share your screen solution, or would you like to code it or approach?
So I haven't coded it. I mean, you can share it, like. But let me check. I'll have to check. In the meanwhile, you can carry on.
Sure.
It's fine if you didn't code. You can code now if you want. It will give you a practice to code on spot.
Yeah.
Or Raghav, you can, I think, explain the approach then.
Sure. So my approach is almost similar, like Shashank explained. So everybody
I
can
can
see
share.
my work. Oh yeah, go ahead. You can stop it.
So it's like for finding the midpoint, slow and hard, slow and fast pointer, right? That concept I'm using. Initially, both the pointers, slow and fast, I'm keeping at the head. Then as long as your fast pointer and fast dot next is not equal to null, keep on incrementing the slow pointer by 1 and fast by 2 step, right? So by
Right.
this time, the slow pointer will give you the mid of the linked list, right? And once you get the mid, the normal, what you say, for reversing the linked list, you just pass that particular pointer to the merge, reverse, first to the reverse list. So it will reverse the linked list and give you the pointer. I'll show you. So yeah, I'll show you. So sorry. Yeah, this is for a normal standard reversing linked list, right? This is your current pointer. Like the way you reverse a linked list, like you'll have a current pointer. You'll have current pointer to your head and previous pointer to your none, and keep on checking if the next pointer is not null. So to the next node, you try to append your currents. Next, you try to append to your next node, and to the current next, you initialize with previous. Previous will contain the null, and just swap previous with cur and cur with the next node. And once it's done, it will return ahead with a 5 as a pointer to that, and just keep on merging the list. As long as both the lists are not empty, to the dummy node you append first one and then increase that one, and similarly for the second and increase that one. And at last, if you check if L1 is left, directly append it. If L2 is left, directly append it. At last, just to return this return dummy node dot next.
Yeah, even I also have the similar solution on a Java. So what I've seen that this problem is very interesting. It is basically a problem of sub-problems. We have three similar questions. The one is slow pointer, fast pointer. We can learn in this question how the slow pointer, fast pointer works. And second thing, we can see how we can reverse it. And the third part is a merge. So it's a three-step problem.
Yeah.
So let me share my screen. So can I quickly go through the same approach in whiteboard so that everybody should get what it is?
Yep, that'd be great.
Yeah, so we have given a problem like this. So 1, 2, 3, 4, 5, and maybe 6. So the output required is 1, 6, 2, 5, 4, 3, or 3, 4. So what Sashank explained in the code is, so basically he first divided into two parts by finding a middle node. Okay, so the first step is find a middle and split it into two list nodes. So maybe you can call it as head node 1 and head node 2. So in the second step, what we are doing, we are reversing the last H2 basically. So the second step would be reverse. So in the reverse step, what we will be having 1, 2, 3, and 6, 5, 4. Then in the third final step, we will merge these two. So where we will pick first element from here in the H1 and point to the first element 6, like that. 2, 5, 3, 4. So probably what I can do is I can share the code also.
We only reverse the second list. Or
Yeah, so we are reversing the second list, 456 to 654. Then in the final step, merge part, we are merging in such a way that picking up the element from here and pointing. So basically, we are maintaining a 4 pointers. I can show my code. So what we are doing in this particular step, we are first running a slow pointer and fast pointer. So maybe I can quickly recap how the slow pointer, fast pointer works. So in slow pointer, fast pointer is you have a 2 pointers over here. One is slow and one is maybe fast. So what fast does is fast takes 2 steps at a time. So so slow take 1 step and fast takes 2 steps at a time. So like if slow becomes here and fast takes 2 steps, so fast moves here. So when slow moves here,
So
so
fast starts
fast
at
moves.
2, not the start, right?
Yeah,
We are saying
it is all depend upon how you want to iterate. It can work in various variations. Either you can start so in general how it works is yeah, you are right. So in this particular code I started a fast pointer from here, that's why. So you can start based on the variation of the question or what is your approach. So the basic idea principle is you have 2 pointers, slow and fast. So slow takes 1 step, fast take
It will be a 2.
yeah. So fast move here. So slow moves here, fast moves here.
Yeah, in your case, if head was null, it would,
Yeah.
yeah.
Yeah, so as Shweta pointed out that it should start together. So that's why the basic idea I'm giving how slow and fast works.
Yeah.
So I can go through my code specifically.
Sure.
So we can take the same example. 1, 2, 3, 4, 5, 6. So in the code, you can say that we are pointing first slow pointer to the head, which is here, and a fast pointer we are pointing to the head, not next. So slow, fast take 2 steps. Slow take next step. So fast take 2 steps. So we have a terminating condition here. If you see, if fast is not equal to null or fast dot text is not equal to null, it means we have reached to the middle of the node. So likewise, we can find the middle. So once you find a middle, so we will split into these 2 lists. And how I'm splitting into these 2 lists is as I shown in the beginning, I named it as a head 1 and head 2, these 2 lists. So I'm pointing slow dot next equal to null, just so that they should become 1 list, so that 3 dot next should be null. And then I'm returning head 2. Head 2 is slow dot next, which is this part. Slow dot next is this part. So likewise, this function would return me head 2, which is the second part. Then once I have a splitting, then there is a reverse. In the reverse, I'm passing the second part, which is 4, 5, 6. And
Hi,
how to
Raghav.
reverse? Yeah.
Yeah, I miss your point. Why didn't we start both the pointers from 1? So we start 1 at
You,
1 and fast at 2.
you can do that way also. There is no issue.
Because problem is if the length is odd, I mean, right now you are only considering the even length list. And in that case, you will just be at one step before, like you will be at mid -1 location if the length of the list is odd.
Yeah.
I think like that you might end up on 4 if you start them at the same place.
Then you may have to
rather
take one step back.
I see sometimes, I have a similar question. I see sometimes, people start both slow and fast at the same pointer to the head. And sometimes they go, this case, slow is the head, fast is the next. In what situation we're going to use, if they both point to the same head? And what situation we need to do like this?
Both will work, I think. I mean, it's not like you can go with both the ways.
I think it depends on the middle element we are looking for. Like if the length is even, then they can be two middles, right? So I think that is what the differentiating factor is.
But we don't calculate the length of the list before deciding whether both the head should be at the same. I mean, both the slow and fast should be at head or a distance position, right? Blindly we are assigning the position and doing.
Because of the distance that the fast pointer is at, then you know the length. But you don't know, if it's even, if it's the left one or the right one, because they're both the middle. Or I guess the middle is actually that pointer in the middle, but it's not anything. So.
Yeah, what I have seen in the discussions forum, many people, they have started from the first node itself, and they have tweaked their solution in such a way that they find the exact middle by -1 or +1, like that.
Then you can have a previous to nullify this to get the head to, and setting the slow dot next. And this while loop, the terminating condition will change in that case, I think. Right?
Yeah, this part will vary in that situation.
Yeah.
Maybe we can also take an odd length one once we are done with this to make sure.
Sure.
Yeah. No, I think you can go ahead with this, and then once we are done with this, we can try with an odd length quickly.
Sure. So I was trying to reverse it. So for reversing also, we have a pattern in linked list. So I will try to explain quickly. So how we can reverse it. So in reverse one, we can have a 3-pointer approach, current, pre, current, and next. So if you see, this is the logic to reverse a linked list. So this logic works well if you have to reverse entire linked list end to end. So what we are doing here is we are in the first step, we will not be having this next pointer. So we are taking current pointer to the head and previous pointer to the null. So if you see here, I made previous pointer to the null and current to the head. So once you go into the while loop, what we are doing is we are taking a next is equal to current dot next. So your next will become here. Then what we are doing, we are making current dot next to previous. Basically, this is our current dot next arrow. So I'm pointing it backward like this. Current dot next equal to prev. So current dot next, this link I'm breaking it and I'm pointing it back to the prev. So then pre becomes cur and cur becomes next. So pre becomes cur, so pre will become cur and cur becomes next. So after this iteration, we would be having our linked list looks like this. Pre, cur and null. So we don't have any next pointer here in the first pass. So in the second pass, what will happen? Your next will become again cur.next. So next will go out, it will point here. Your cur.next, which is this link, this will get moved, it will point to pre like this. And then pre will become cur and cur will become next. Take out the pre, put it here, and cur will become next. So your linked list will start looking like this. So likewise, you will go again. Next will become cur.next, which will be here. Cur.next will point to prev, like this. This link will go out. Then prev become cur, cur becomes next. So in the last pass, your cur becomes null. So which is the breaking condition of this while loop. So once you reach here, you just return a prev. Where prev is pointing to 6. And if you notice that this part is reversed now, which will become 6, 5, 4. So basically this is the typical classic way how to reverse a linked list using 3 pointers approach. So we reached to the second part we solved the second part of the problem where we reverse the second half 6 by 4. Now the last problem which I found is tricky when I was solving this and trying to understand, where we have to merge this list. Okay, I think let me clear it. Some portion. Okay. So now we are at the final step where we are going to do the merge. So in the merge, I took 4 pointers. Okay. So the first is I'm making it cur1, which would be my 1, 2, 3. Okay. And then C2, which is head 2. If you see in the merge function, I'm taking 2 list nodes, head 1 and head 2, which was these 2 list nodes, which we have reversed it now, and it has become our head 1 is like this and head 2 is like this. So I have 2 cur nodes, and this is 6, 5, 4. And I'm maintaining another 2 pointers, which I'm calling as next pointer. And how I'm doing is I'm taking cur1, next pointer would be cur1 dot next. These 2 steps. Next one is cur1 dot next. So cur1 is pointing to 1 and cur1 dot next would be 2. And n2 will be cur2 dot next, which is 6, and 6 dot next is 5. Like that. So then what I'm doing is I have these 4 pointers ready at this stage. Now cur1 dot next equal to cur2. Cur1 is 1. Dot next we are pointing to cur2. Cur2 is 6. And then at this stage, maybe I will write it here. 6. Cur2 dot next. Cur2 dot next is 6. Cur2 is 6. 6 dot next is next one. And next one we have stored it here already. So this will become 2. And then in the last, what we are doing, we are pointing cur1 dot cur1 equal to n1. So where n1 pointer is, n1 is pointing to 2. So basically cur1 we are changing to 2, pointing to 2 in this list. So for better understanding, I made it like this, but actually everything is happening between cur1 and cur2 only. So this one will go out and your cur1 will start pointing to 2 now. Same way, cur2 will start pointing to 5 because we are saying cur1 equal to next one, cur2 equal to next 2. So in the first part, we got this result 162, and this is the how the pointers looks like. So in the next pass, again we will update our next one and next two. So which is cur1.next, cur2.next. What is cur1 is 2, 2 next is 3. So our n1 become 3. In n2, it will become 4. Then we have a cur1 is this, cur1.next, which means 162. So we are saying pointed to cur2. And what cur2 is holding right now? Cur2 is holding 5 as a head node. So you will get a 5 over here. And then cur2.next. Cur2.next means 5.next will again point back to n1, which is 3. Again, in the last step, what we will do, we will update our cur pointers to the next pointers. So right now, next pointer is pointing to 3. It means cur1 should also point to 3. N2 is pointing to 4. It means cur2 also should point to 4. So in the last pass, what will happen? Again, we are saying cur1.next equal to cur2. So cur1 is over here. It will point to cur2. Cur2 is 4. 4. And cur2.next equal to n1. Next, I think I missed it. I think it will, wait a minute. Cur1 is 3.
So if one list
Okay,
gets
so
over,
I think this is become null because in the first step, next one equal to cur1.next. So cur1.next is null. So this n1 is null now. So I don't have anything to update over here in the second pass. So same way the third iteration will happen. So in the third iteration, cur1.next equal to cur2. Cur1.next is cur2. What cur2 is holding? Cur2 is holding 4. So it will become 4 here. So then cur2.next equal to next one. And I don't have anything left because everything is completed. And when you will do next one, next two update, so these all become null. So in these 3 iterations, you will get this result. And this is what our output we are looking for. Yeah, Shashank, sorry, I stopped you. Would you like to add something here?
I was saying like how you are taking care, let's say first gets, the length of the first list is shorter than second. So first will get over, right? Then you will be left with the remaining elements of second. So
yeah, at a time, either you would be having elements in a n1 or elements in n2, right?
okay.
So in either situation, one will be null. So because the way we are calculating middle is, if you are having an odd list, maybe 1, 2, 3, 4, 5. So it will be like this. So your n1, your n your, what I'm trying to say that in the end, n2 will become null in odd scenario. That is your question, right? How we'll take care in an odd scenario.
Oh yeah.
There's only one element extra, so we don't need extra while loop to add all the element to the end, I think.
Yeah, because in the end we will be over with all this cur1 and cur2.
Yeah.
I think my bad, this diagram become very messy.
No, it's good. Like
so, this is a third part. So that's all for this question. So first we found a middle split by using slow pointer, fast pointer approach. Then we did a reverse. A reverse, we found how to do a reverse using pre-cur next approach, 3-pointer. Then final, the merge part, we did it using maintaining these 4 pointers. So any questions, thoughts? Anybody have some other suggestions, or we can improve something here?
Yeah, one thing just I wanted to call out that I think the approach what you have taken for the slow and the fast pointer, maybe that makes life little easier than starting slow and fast from the same like the from the head pointer. Does like
Yeah,
I mean
I tried with that approach. Somehow I missed it and I started getting a cyclic redundancy error. So I could not find the time. So as
yeah
Shweta mentioned, I messed up somewhere in my while loop where I was switching it. So there the
yeah I think
mistake.
you have to go one node back at that point, and the only catch will be what Naga said that you have to check for the null for the fast pointer, right? But I feel that that will make life easy when you start your fast from like one node ahead, because then you won't be going away from that middle node,
Yeah,
right? Yeah,
I
I think
totally agree with you. I don't have that solution ready. It got rejected in lead code and it was keep on giving
yeah no, that's fine. I mean,
cyclic
just
redundancy
for
error. Yeah.
discussion, like if somebody has any other
Yeah.
point we can discuss, but I feel
But
that
overall, do you find any other approach at very high level, like apart from following these 3 steps? Because I could not find any other solution which is easy to understand or easily I can write
I
it.
have tried the recursion, just it came to my mind that just attach first and last and then second and last. So, but in that case, you have to go over the list multiple times. I can share that it worked, but it is not because it has many times you have to go over all the lists. So I can share that my code.
Sure.
Give me a second. So in this case, you can see, right, my screen?
Yeah.
Yeah. So I have this reorder list and I have this helper function. In this case, if I'm just checking this node.next and node.next is not null, return the node. So the merging part, I'm doing it here, if you can see. This node is equal to node.next, and this while loop, I'm going till the end to find the last pointer. So if you see here, I have the result node which we will return for the helper, but in the this previous node, the while loop will go till the end to find the last node. So this current node will have the last node, and I will attach to that first node what we got it in this helper function. And then helper node will have, so the second time when we are getting to the helper node, it will have the node from the second node to the last second node. So that list is getting shortened every time by removing the 2 nodes from the first and the last one.
Yeah, that's interesting actually. If we could reduce going through the loop again.
Yeah, every time we are removing first and last. So the second time when we are going in the helper node, it is getting the second node and the last second. Again, it comes and it reduces that. So it works, but you have to go to multiple times to to traverse the list, shortened list. So time-wise, I think that splitting into two and then merging is better, but for the recursion, just I tried and it worked.
Is it like a kind of combination of both iteration and recursion? Because we see the while loop.
Yeah, while loop I'm doing to get the last node. There's no other way to access the last node. So every time I have to do the while loop to get the last node. And in the recursion is only the part where we are passing that shortened list to get again first and last node. So if you see how many times we traverse the list depends, like if the list is very big, so we have to go that many times to get the first and last node.
But still the runtime is quadratic, right?
Yeah.
O of n
What
square?
I didn't get it?
Runtime is O of n square? Or?
Yeah, quadratic runtime.
Yeah. So it works, but the time optimum solution will be splitting into two. And initially I solved like that, and then said I got that thought that can we try this? So it worked.
So for the while condition exit, right? You always sorry, you always go to the end of the node, but we don't have to go to the end of the node, right?
But we have to get the last
end of
node
the
to
list.
attach to the first, right?
To get to the, but
so,
in the second loop, you would have to go to last but one, right?
Let me tell you again. When I'm coming to the helper function, first node is what we are getting in the helper function in the result, and that is what we are returning. Second, in the result.next will be the last node, right? So somehow we have to retrieve the last node from the list, what we got, right?
Yeah.
So to get the last node, I'm doing this while loop till the time we have the current, and current.next is null. So this current is now, after while loop, the current is the last node, right?
Right.
You got my point?
Yeah.
So I'm attaching the last node with the result, that is result.next current. Previous node, because we are using the last node, we have to terminate that node. So previous.next, I'm making it null, so that in the end we don't have any node because we already used the last node, right?
Yep.
So now current is the, you can see here, right? We have the current result.next current is the last node. Now to the current we have to attach the third element. Second element. So this node is the right now at the second element because we have the node.next. So that I'm passing to the helper function. So helper function is now from the second node to the last second node.
Okay.
So whatever that returns, it will be attached to this current.next.
You can scroll up a bit. I want to see the main function actually.
Main function is just calling this.
Okay. Yeah. Do you mind sharing the code?
Yeah, I can just share it on the chat. Yeah.
Thank you. Yeah, it's an interesting approach. I don't know if you can optimize it, but yeah.
Yeah, there's no like we cannot optimize it. I thought about it. If something comes up, just share on the.
Yeah. Thank you.
So there's no way to to find the last node without using the while loop.
There is none, right? Unless we split and reverse. That is what we did in the previous. Because in the linked list, we just have the head node. So unless we split it or do something, we don't have to access that last node.
What if like we just let it go to the end of then we have pointer to that last node, right?
But we don't have the previous node to reverse it, right? If we reached first time to the last node, and if we have access to the previous node, that if we have the parent all the time, then we can traverse back. But in the linked list, unless we create one different data structure to have parent node and then use that to traverse back, then we can do that. But we don't have.
When we at the last node and then we go back, right? That would be the previous to the last.
That will
right?
be only one, right? Because we are always modifying the previous. So previous, we will have only last two nodes, not before that.
Okay. Yeah, I haven't tried the recursion. So.
But Leon, you're right. So if we are using recursion, somehow we can preserve the previous nodes in the stack. But that way you are like save, you are retaining you're keeping the track on like you are using space then. So it's recursion. So I'm trying to say is so we are on the frames and the previous frame do have the previous node, and somehow if we can use that.
Yeah, I was thinking, I haven't done it, but we're thinking maybe, you know, we return, we would have the, we also return the result, you know, from the recursion so that we can.
Yeah, we can save it in separate data structure, all the previous nodes, and then we can use that. But that will take, again, like we have to create the data structure and use that. That is what my, we can try that. Like if somebody comes up with that approach, that will be nice to optimize. Then
Space complexity will be of n, but the time will be of n as well, right? If you save into some data structure.
Yeah. So let me.
So even with the iterative we have, that would be big O of 2n, right? Because we need to reverse the second half, right?
It will be only 2n, not like n square. In this case, it becomes the n, like n square, because we are going multiple times. In this
but
case.
in an iterative approach, each step would be considered as O of n. Then in the final, don't we consider as order of n only?
Yeah, but let's say we go with tie the bow, that would be 2 big O of 2n, right?
3n.
Yeah.
Okay,
3n
so
is again still on, right?
Yeah, 3n. Yeah, on.
Yeah, so my question is, can you optimize it to run only big O of n? Only one
single, that means
yeah.
single pass you're saying, right? No,
Yeah.
I don't think we have the option of doing that. That is my understanding, because anyway we have to split it to get access the list.
I think what Leon is suggesting is, in this case, if you use space and then it becomes O of n.
Yeah. In this
but
case,
the other approach
yeah.
O of 3n, right? So this.
Yeah.
No, I'm talking about the iterative, not
He's
in
not
recursion.
talking about. He's not talking about this. That is what I got.
Oh, even the iterative.
So if you
let me stop sharing then, so that others can share if that we want to see the code.
No, we can go back to. So what I'm saying is, instead of reverse the second half, you reverse the first half. That way, you know, you run only big O of n, only one iteration. Because if you reverse the second half, you have to do it like, you know, one more extra big O of n, right? One more n time, right? But if you reverse the first half, then, you know, when you find the middle, you reverse at the same time. Then by the time you get there, you know, you only done n over 2 operation. And then, you know, the second is, you know, you just do the merge them, and that's another n over 2 operation. So the total will be big O of n only. I mean, only one iteration only.
So you're saying like reversing and getting of the middle linked list in one pass.
Yeah.
And reversing the first half and getting the middle of the linked list in one pass.
Yeah.
But again, it will be O of 2 n, right? Next time.
No, only big O of n. Because when you find the first half, that is n over 2, right?
Yes.
Then you already have, by the time you find the first half, you already have the reverse of the first half.
But
right?
we have to return the head, right? If we reverse the first list, then we are getting 3. And I didn't get that part about how it helps.
Okay, so when you merge them, you prepend it to the head, right? So the key is to prepend it to the head, not to append. So you keep prepend it to the head, and then, you know, at the end, you have only, at the end, you have 1 and 4, right? That would be the head of the linked list.
So Leon,
let's say initially,
this is the recursive one what you're talking about, right?
No, the iterative one.
Oh, okay, sorry. Yeah.
Yeah. So just think about this
Leon,
way. Okay, we have after we reverse the first half, we have 3, 2, 1, right? Right, and then when we you know put 3 and 2, I mean 3 and 4 together, right? Then we put 2 and 5 together, and when we put 5 and 2 together, we prepend it to the to the result, right? So because we prepend to the result, then at the end we have only 1 and 6.
So you'll use 3 pointers, right? 3 or 4 pointers.
Only 2 pointers.
How will you prepend 2 to 5 when you're?
So let's say when I prepend 3, so I prepend 1 and 4, right?
Okay.
Right. So what I have is like, what the result I have is that 4 and 1, right?
1, 4, right? 1
yeah.
Year. Okay.
Because after reverse, I do it.
1 and 6, right?
1 and 6.
No, I already reversed the first half. So now my head would point my, you know, the head of the linked list will be pointed to
1.
Yeah. Right.
Yeah. Yes.
And then now I merge 1 and 4. Right.
So do you have point? Oh, okay. Yeah. Once next is 4. Okay.
Yeah. And then now the next one will be 2 and 5. Right. And I prepend 2 and 5 to 1 and 4.
So 2 and 5, how will you prepend to 1? For you need to have pointers for accessing 2, right? Or how can you go to 2? Like initially your pointer was at 1. So 1 and 4 got
no, initially my pointer was at 3, right? Maybe is that
why we are pointing 1 to 4? Can you explain, Leon, why we are pointing to 1 to 4?
Oh no, sorry, that's not 1 to 4. I mean, after reverse the first half, what do I have? I have 3, 2, and 1, right?
Okay.
Right.
So now I merge 3 and 4, right?
Okay, 3 and 4, right?
Right, and then I advance the head, the pointer. Now my head will point to 2 and 5, right?
Oh, yeah. So,
now
but where? Okay, yeah, fine.
Now I prepend 2 and 5, you know, 2, 3, and 4. Right?
2 and 5 to 3 and 4,
yeah.
Okay.
Right. Now, you know, my head would point to 1 and 6. Now I prepend 1 and 6. Right?
But how do you go back from 3 to 1?
Yeah, that is like.
Go back from 3 to 1? Because I already reversed the first half.
Okay.
So if I reverse the first half, the head of the list would point to 3 initially, right?
Okay.
Yeah.
After I process 3, it point to 2.
Okay.
After I process 2, it point to 1.
So you're doing it the way he did it in opposite way.
Yeah.
But
So
the
this
output
way
almost is similar, right?
Yeah.
Oh, yeah. No problem.
Still, it's not trivial to like.
It's the same, but instead, like look at the normal operation. What you do is you keep appended to the end of the result. You know, I just prepend it to the result.
Oh.
Yeah,
That's
I think
only
that
different.
yeah, prepending actually maybe that would work for the recursive way, and we could avoid using that while what Shweta was doing. You know, maybe there is something you can do there. Yeah, I think that is a good idea. Yeah, yeah.
The visualizing is bit because he's prepending. That's why.
Mm.
Yeah. Yeah.
Okay. Yeah. Good. Thank you.
Can switch to next.
Yeah. So moving next, this is very interesting problem. So linked list cycle. So we have a linked list available 3204, and there is a cycle in that linked list, and we have to return where the cycle begins. So in this example, if you see 3204 and 4 is pointing back to 2, it means cycle exists, and the output should be head of this node where the actual cycle begins. So so another example is 1 and 2. 2 is pointing back to 1, so it means cycle exists. So we have to return head of this node, which is 1. So if there is no cycle, you can return just nothing. If there is no cycle, you can return a null. So this is the problem. So anybody wants to share the approach or any code if they have done already?
So one approach I can think of is let's use a hash map, and we keep on adding the not yet encountered nodes. And if we find like if my next node is already there in the hash map, then that next node is the cycle head.
Yeah.
Yep, that is a good way to find a cycle. But how we are going to return the index of the start of the cycle?
So index is needed. I thought the node. We can like start with say position 0 and maintain a key value pair of address and position. And if an address is already there in my hash map, then I return the value at that address. That would be my position.
You have to return the node or position.
We have to return a node.
So I thought it's index. So if it's the node, then I can simply dereference that address. What is it? Do we need the index or the value?
Yeah, say return a node. So the address of it.
But
Yeah,
what's
we
the
have to
question?
return the node.
I mean, if there's a map of pointers, and if the same node exists in the map, we'll say, okay, this is the very first node of the cycle.
Return the node. The value, I mean, I don't know. Maybe the value or the pointer.
Yeah, the node would mean the reference.
Correct.
Yeah,
So the pointer. I thought there's a version of this problem in which you're not allowed to use auxiliary data structure.
Yeah, could be. I was just suggesting a
Sure.
brute force.
Yeah, Yeah, no, that would be the way I do it too. I think there was something with like the distance and a couple other variables that allows you to solve it without doing that.
Okay, let's say
pointers.
don't need to use additional data structure, then can I have two kind of for loop? The first one point to, for example, the first node and run all the way. But but I don't know what the size of the linked list. Huh?
I think we have to
was
use
thinking
the
like,
two-pointer, right?
Yeah, kind of like for loop run completely. The first for loop, if I point back to the the same node, if it, then I return it. Otherwise, I have advance the pointer and run another loop.
One thing you could do is after the slow and fast pointer meet, you can you can maintain the nodes in a set and start after having all the nodes in the list set. You can start another pointer at the head, and whichever is the first matching, whichever is the node that is already existing in the set, that would be the start of the cycle.
Yeah, that's that we discussed in the first approach, but the question was we cannot use additional memory.
Then you have to use distance itself. I mean, where the slow and fast and slow meets, you start another pointer from the head, and when both of them meet, it will be the start of the linked list. I mean, the start of the cycle.
Cycle,
yeah.
Yeah. Yeah. Thanks, Uday, for bringing that proposal, and Leon. Yeah, even my approach is same. To first identify a cycle, either you would go with the hash map approach or you go with the slow fast pointer. Once you identify a cycle, then you start another pointer, and there is a mathematical theorem based on flowed algorithm. Using that, we can prove that the distance of a second pointer and where the meeting point is there, the distance would be same. So based on that, we can find the start of the cycle.
It's kind of funny actually, because when I'm looking at this and then the solution that has those two pointers, it looks like this would be one of those scenarios where you might want to have like a prev, like we were talking about for finding the middle node, because it kind of is that the middle is going to be where the cycle actually begins again, because that would be where it ends, right? So the interesting thing here, I guess, is like you could have a prev, and then if you just point that prev dot next, it will be where the cycle is. I don't know if that makes sense.
So
where your fast pointer is.
But we don't
you'll
have
go
any
over
idea
it otherwise.
where fast and slow is going to meet. They can meet at a very arbitrary point.
They could meet at any one, right? But like, isn't the next one going to be wherever the last one for the fast would be? Because isn't that the end of the cycle, or the end of the loop, or the end of the linked list, basically?
So how about this?
So if they end up, let's say.
So 3, 2, 1, 0, 5, and you have something like this. Okay, and maybe, okay, let me add one more. So what I'm trying to say that so say for example, somewhere here, this is the meeting point. Okay, this is the meeting point, and this not meeting point. This is actually start of the cycle, and meeting point is somewhere here, where slow and fast is meeting. And if you have another pointer which is slow too, so if this is the meeting point, so next, as you were saying, next of this would be 5, and next of this would be 2, but actual cycle is this. Uh, uh, did you get my point? Codes?
Yeah, I think that does make sense, because yeah, it won't just point back to the middle.
Because you don't know,
Yeah.
the distance is not only going to always have a one step, it can be a multiple steps too. Yeah, someone want to code it, or do they have solution, or they want to share their screen for this approach? Okay, I think I will start it then. So how we can solve this is, first thing is, this problem can be solved in 2 steps. The first step is you have to identify a cycle. Okay, identify a cycle, and then second is you have to return where the cycle starts. So to identify a cycle, there are 2 ways. The first way, like Uday was saying, that you maintain a hash map, and if the same value come next again in your hash map, then you can easily say that, okay, this node came again, which I was keeping on track. It means there is a cycle. So another approach is you can have a slow pointer and fast pointer approach again, where you can run the fast pointer by 2 steps, slow by next 1, then again fast by 2 steps, slow by 1, then again fast by 2 steps. And the moment your slow pointer uh, mates with the fast pointer, it means the moment you get this condition, fast equal to slow, okay, it means the cycle exists. So in the past question, we have seen that how the slow and fast pointer works.
Raghav, one thing.
Yep.
Yeah, so I don't think it's mandatory to maintain the relative speed as 2. I think we can take it as anything, because our only aim is to find whether they meet or not, and that would be true for any 2 speeds, right?
That is very interesting thing. I did not think in that way, because all the problems I'm running mostly two steps and 1 step. But I think we can do that.
I think
Not
that is
sure on that.
well, but how to find the cycle where it starts, that could not be done if we have 3x or 4x.
Yeah, I think it would done better, I guess.
A couple things with that
I
too.
think,
Like one is that you have to return the node, right? And then the other is that it should run in like optimal time. So I'm not sure if it'll affect the time
Raghav,
complexity.
Yes, Pankaj.
if GCD of the speeds is 1, we are fine, because that will definitely ensure they'll meet. I mean, you can't, I mean, the speed should be different. I mean, it doesn't matter it's 1 or 2. But I think, yeah.
Yeah, what Asim is pointing out is that when we are going, yeah, for sure we are going to identify cycle is there. But what Asim's point is, if you run at a different speed, how you will identify uh, the start of the cycle? Because we are going to use a mathematical equation to prove that.
I think we are using the same algorithm, which tells like use start and fast to find the point where there is a cycle, and then same algorithm extends to find where the cycle starts. So
So
the
do you
algorithm
think
has
if
the
we
speed
run?
of 2x.
Yep. So I think I can explain that algorithm first. What algorithm is saying. Maybe like this. So say for example, we have 3 nodes like this, okay, and we have a slow and fast pointer over here, and the distance between this node and this node is, let's assume it is k, and distance from this to this node as y, and this as x. So this is our meeting point, okay, where the slow and fast is meeting, and we know that cycle exists. So how the mathematical equation is proven that how, so it means slow and fast met each other here. So how much distance a slow pointer took to reach from here to here? So it took k plus y, right? First slow move went to here, then slow went here. So it took k plus y. And how much distance fast pointer took? So fast started from here, then it went directly here, okay? But that time slow was somewhere here, not here. So it means first fast took k plus y, and by the time of the next iteration of the slow pointer, when slow came here, the fast took another cycle x plus y, right? So which will become k plus x plus 2y. So what we're trying to say that when slow and fast pointer met here at this meeting point, the distance slow pointer took is x plus y, and the fast pointer took distance k plus x plus 2y. And the speed of the slow pointer was 1 step at a time, and the speed of the fast pointer was 2 steps at a time. So it means our fast pointer is 2 times the slow pointer, the speed of the fast pointer. So we can say that the distance of fast is k plus x plus 2y is equal to 2 times k plus y, and which will become 2k plus 2y, and this 2y got cancelled, 1k got cancelled, and what we got in the end, x equal to k. So this mathematical equation says that, proves that the distance x is equal to k. So what is distance x and distance k? If you see, this is the start of the cycle. And this is the distance k. And this is the distance x. So this equation says that your k equal to x. It means if your slow pointer or any guy, any random guy, maybe p, if it takes a distance of k to reach here, if any pointer is over here, if they can also take a distance x, so it means the cycle exists. So how we can use this equation in our solution? That, let me rub it. I'll make, so let's take the same example. So we have a slow pointer, fast pointer. So first, let's okay, you can move any pointer. So fast we move here. So fast reaches here. Then slow comes here. Okay. Okay. Sorry, I missed one node here. So slow, fast starts here. Fast reaches here. Slow starts here. Slow starts here. So again, fast took 2 steps. Then slow move here, then fast move here, then slow again. The moment F becomes S, so it means cycle exists. Now, if we can have another pointer called as S2, which will again point here, and already we have a meeting point here, and our slow pointer is at this position right now. Even fast and slow both are. If we will move this slow pointer further and S2 further, the point where S2 and slow pointer, this S, the moment S2 meet S, it means that is the start of a cycle. So we can take the example, one more example to visualize this.
Raghav, one quick question. Like, I don't know if you are explaining the same thing, but how is x is equal to k is relating to that's the start? Can you explain that again, please?
How x equal to k is related
Yeah,
to?
yeah. We derived the formula that x is equal to k, right?
Right.
And then how is that relating to when S2 and S meet, that's the starting point? It wouldn't relate from the formula to the actual solution.
So it looks like
Okay.
where they intersect from there, if you start moving, and from the head, if you start moving, where
Yeah.
there will be, that will be the starting of the cycle.
Yeah, I get that. I mean, like, I got that solution, but I was trying to understand how this equation has helped us.
No, so I think there could be like a follow up in the interview, like explain how that works.
Yeah. That's what I think we have.
And I think this equation will help as somebody asked this question, right? Like if you are taking not the twice the speed of the fast pointer, but 4 times or 8 times, right?
Mhm.
So I think this equation in some way will help you to derive to that, like how many times you have to go through to reach to the starting point. I mean, that's what I'm thinking. Like if f equal to 4 times s, right? Then this won't be x equal to k any longer, right? So it will be some times of something, right? X equal to 2k, 3k. I'm just guessing. I mean, we have to derive that. But the same analogy may not work. Looks like if you start from the head and the meeting point with the same speed, you won't reach to the cycle. But you have to follow this equation, whatever the end result is. I mean, that's what I'm thinking right now.
Okay. Yeah. Maybe I'll try that with a couple of more examples and see. Yep, cool.
Yeah, to answer your question, Naga, we can visualize another diagram here. So we have, say for example, this is a node we have a slow and fast here. So let's try to run the pointers first. So let's move the fast pointer 2 step, slow as 1. So fast will move here, slow will move here. Now fast is moving here, then slow is moving here. Again fast is coming here. So if you see now, slow, the moment slow met fast, that time we have a breaking condition.
Yeah.
Okay. So maybe I will share my pseudocode also. Let me. So what we are doing here is we have a fast pointer and we have a slow pointer. Okay. Fast is moving 2 steps at a time. Slow is moving 1 step at a time. The moment fast becomes equal to slow becomes fast becomes slow, then it means at this stage we know the cycle exists.
Right. Yeah.
And we know the meeting point.
Mm-hmm.
Right. Now we took another pointer which is slow 2. Okay. So let me make it. So we took another pointer called as slow 2. Okay. And our last slow pointer is here. Okay. Now what we are doing, we are moving slow pointer and slow 2 pointer 1 step at a time. Again, so this slow was here.
Mm-hmm.
We are moving slow here. Okay. And this slow 2 moving here. Again, we are moving this slow here and this slow here. If you see here, the moment S2 and S is meeting, that time we are claiming that this is the start of the cycle. And if you see how much distance slow 2 took, it took this much distance. In the steps term, it took 2 steps.
Yeah.
Right? But 2 steps equivalent to X.
Mm-hmm. Mm-hmm.
Oh, sorry. K.
Yeah, K in our case. Yeah.
So now, yeah. So when we started this inner loop, this while loop, where the slow pointer was somewhere here, right? At a meeting point. So slow also took 2 steps, if you see.
Right.
So 2 steps equal to 2 steps. That's what we are trying to say. Whatever distance slow pointer will take, and it's the same distance slow 2 will take, wherever they will meet, that would be the start of the cycle.
Okay.
Does it help to understand, Naga?
Yeah. Makes sense actually. Yep. So the distance from the start and the distance from the meeting point to the intersection will always be same. Yep. Okay.
Yes. So this is K, this is X, this is Y.
Where it is. Okay.
So this was the meeting point.
Mm-hmm.
So this was a slow fast, and slow and fast met here. And that time slow took K plus Y and fast took this much distance. So then we know that fast is running at a speed of twice the speed of slow pointer. So then based on this calculation, we came into this part, the distance would be same. So with that assumption, when we started running the slow pointer and slow pointer, second slow pointer, wherever they are meeting, we can safely assume that that is the meeting point, means start of the cycle.
So if we do four, like someone was asking, like if we do fast pointer goes like 3 hops or like 4 hops, this wouldn't work, is what we concluded. Right?
I think we can calculate somewhere here.
Yeah.
So
actually,
in that scenario, it would be.
I calculated that actually. So that equation is little different. Like it becomes for 4 times, it becomes X equal to 3K plus 2Y. So I think that will not apply here. Looks like the same strategy. I just did a 4 time S equal to F, and then I just used whatever Raghav explained here, and the equation is little different. So I'm not sure if that will work.
Oh, okay, makes sense. Then it's always have to be like 2 hops.
Yeah, looks like.
So there are some good videos from Gaurav and GKS Gaurav and some other folks on YouTube. If you search flowed algorithm for identifying a cycle, start of the cycle, there are some good theorems are available. But I found this theorem is very useful. A good friend of mine has shared with me, and that is very easy to remember and to prove in an interview also. So
Yeah.
this is we are saying that.
Yeah, that's the reason I was trying to understand. Like I remember this solution. I mean, like it's like you have to find a circle, you do this 2 pointers, and you have to find the meeting point, you do that. But as this way really helps to talk in the interview, right? Why does that? Why do we go like that? Yeah. Cool.
So,
Thanks.
And I think I remember somebody told me, like somebody was asked in an interview that don't follow this approach, follow something else. And I think somebody at the start suggested some approach about the hash map, right? I think that is one of the idea. I'm just sharing that I remember like 4 or 5 years back, somebody asked me, I shared this experience saying, can you do this differently? Same problem.
Yeah, I think that's only space complexity. If you want to take some space, the other one would be the way, right?
Yeah.
Yeah. They might
In
ask
this
as
way,
a
it would be
follow-up.
order of one, and time complexity would be order of one.
Time complexity
So-
be order one.
No, other way. I said space is one.
Oh, space is order of one. Okay. Now, suppose
I
space
think.
is also of n.
Oh, sorry. Yeah.
Yeah, I think there's a difference in f distance actually. I mean, f might not be actually f k plus y plus x plus y. It can be multiple of, I mean, k plus multiple of that circle length plus that y.
Yeah.
I mean, it won't be k plus y plus x plus y. So if you take if you take the start of that, I mean, before the circle, there's a linker list, right? So if you take the linker list as linker list length as far greater than the length of the cycle, you will see that the fast pointer travels more than once.
Yeah, correct. But I think this equation is based on like you met in the first time only. Like it is simplified version. There could be multiple cycles. Then we have to account how many times they both are in the cycle.
No. I mean the cycle. No. If you are moving twice, I mean I'm guessing that slow pointer will not cover more than once the loop, but fast pointer will move multiple times. I was trying to say that.
So what I have seen that if you have a I just added a new node in the beginning. So, and in this situation, what I've seen that meeting point would be always here. I ran a couple of examples. Okay. So if I have we can try it out. If you see here.
Yeah. Actually, it.
So I added here. So what I've seen that the meeting point will, the fast and slow when it rotates. So it will go one step back if the more nodes are getting added. So if you have another node here, then meeting point would be here.
Yeah, it would be that length of linked list mod
distance.
the circle. Yeah.
Yeah, and this, what I've seen, this distance between meeting point and this is always equal to this.
No. That is what I'm saying. It will be if the length of the linked list before the loop will be k. It will meet at k mod c or something like that.
I did not understand that part.
If the length of the linked list is k, I mean before that loop. So that is what you have written, right? K plus y. So k is that length of the linked list before loop. So it will meet, and if the circle length is c, so it will meet at k mod c, I guess. Yeah. So if you see that, I mean that will be equal to this 3 nodes. So if you add some more nodes, it will still be that 3 itself. I mean that that comes out, that meeting point comes out to be some k mod c.
K mod c. C
Yeah,
is
the
the
c will just.
Would you like to share your screen to do that calculation? Or, because
yeah.
I'm getting hard time to understand this.
Okay.
I think you can also annotate on the same screen if you want to.
Yep.
Okay, let me try.
Go to view options and annotate. I guess so.
Are you trying to find an option?
I am trying to explain why it would be k mod c.
Okay.
Are you sharing already, Uday, or are you trying to find how to share?
I am actually writing, so if some is it is not visible.
Yeah, no, we're not able to see it.
Okay, sorry. I mean, I'm trying to use that annotate and I'm trying to write it.
Oh, is it? It didn't work? I found that interesting. Oh, I'm able to do it.
Yeah. Okay. It was
That
you.
was me actually. So. Just go to the view.
I just got a green pointer on the top. Uday, it was you?
No. I'm trying to write it in test actually.
Oh,
okay.
Yeah, the green word was me. I was just trying to see if it is visible to everyone.
Yeah, I drew a circle there, so I don't know.
Maybe I will. I mean, you can go and discuss. I will try. I mean, I will write it somewhere and I will share it in the chat.
Great. Okay.
Okay. Yeah, I think this summarizes the approach of our last question. What we did, we identified the cycle first, and once the cycle is identified, we took another pointer and we moved that pointer and existing slow pointer one step at a time, and wherever they are meeting, we are returning that pointer. So that would be a node where the cycle starts.
Yeah, excuse me. I think I also have some thoughts on where the cycle starts actually. So should I share?
Yeah, sure.
Yeah. So yeah, you need to stop sharing, I guess. Yeah. Thank you so much. So is my screen visible?
Yes.
Yeah, what I think is we can take the distance analogy. I think some of it might have been discussed, but still, I would like to start. So there's a loop here. So what I'm saying that in this case, if we start the meeting point for fast and slow is this point, this 4. So what I'm saying, the distance covered by f will be x, suppose, and the distance, 2x, and the distance for slow is x. So what I'm saying that this distance is x, and the remaining one is another x correct? From 4 to 5 to again 4. What I'm saying, because slow and fast will be at the same point once they meet. So slow has covered x distance and fast has covered 2x distance. So what I'm saying that suppose this distance is y. So so we need to find this point 3, that from where the loop starts, correct? So to get that point, I think how many hops S have to make so that it reaches that point, and we need to prove that that same number of hops head will have to take, correct? So thinking of that, this distance will be how much?
X minus y, or so what is y here? I didn't get, like, what is y?
Y is distance from
From the meeting point to where?
the length of the loop minus f, minus slope actually. I'm just trying to prove this point actually, how you know same number of hops will S required and head required. So suppose full distance is L, and so x distance will be taken by S, so remaining will be y. So this will be just saying x minus y. So what I'm saying that this distance will also be y only. That means same distance y will be taken from for head, and y will be also taken by slow to reach 3. So this is how we can prove that same number of hops. So that will prove that we reach the starting of the loop. That's what I'm saying.
So what is y here? Y is a meeting point, and to the point
End
where
of the list.
where the
Yeah,
loop is.
consider
Where
the
the
distance
loop is.
between meeting point and the end of the list.
So L is equal to x plus y, you are saying, right? L is equal to x plus y.
Yeah.
Okay. L is x plus y.
So I think from the meeting point, if slow hops y distance, and from head hops y distance, they will reach at the start of the loop. Does this make sense, or should I explain a bit clearly?
Guys, there's one page on Stack Overflow. Do you guys want me to share? So it provides a formal proof of this theorem.
Yeah, that's fine. Yeah, sure.
Should I share my
Yeah,
screen?
Yep.
Give me a second. Suppose this is a linked list, and this is the start of the linked list after x distance, and meeting point as from y, and remaining what we are talking about z, and what we are trying to prove is x is equal to z, right?
Yeah, I think this is the same equation which I took.
Yeah, right. So he's proposing that suppose we meet the fast pointer travels x plus y distance and plus some multiple of length of the cycle. So that's a total what fast pointer is traveling, and which is actually equal to twice of the what slow pointer has traveled, which is twice of x plus y. So the slow pointer has traveled this much x plus y, and this is actually then the fast pointer has traveled twice of this. So we are proposing that fast pointer has traveled x plus y plus some multiples of this cycle, this loop. And finally, he proves this that the x is he's trying to prove that the x is x mod L is z. So that means m is x plus y. So x plus y equals to KL. That means the sum of x and y is equals to the multiple of length of loop.
Do you mind sharing it in the chat as well, the link?
Yeah, sure.
I shared the link in the chat.
It is.
I used OCR.
You did.
Okay.
Yeah, this looks interesting equation. Another equation to prove this.
And
We'll go through this offline.
Yeah, and what I was thinking that if both pointers are not are not like the fast pointer is not traversing twice the speed of slower one, suppose it's running at a multiple of n, so this 2 will be replaced by n. So then it would be n times x plus y equals to m plus kl. So okay, but I need to give some more thought, because the way I'm thinking is it should work for if the port pointers are not running or they are running at different speed, this should also work in such cases. But I don't have proof right now.
All right, guys, I'm just going to stop the recording.